Swayam Prabha. Digital India. Educated India.
Greetings everyone, I am Anusha
And I am Nandini.
We are from class 9th B from Ramjas International School. Today we are going to dive into the fascinating world of buoyancy. To make this concept come alive, we will engage in live demonstration to show how buoyancy affects us. But before, let us know what buoyancy is.
Buoyancy is the upward force exerted by a fluid on any object immersed in it. If the density of the object immersed in the fluid is greater than that of the fluid, it will sink. But if the density of the object immersed in the fluid is lesser than that of the fluid, it will float on the surface. Buoyancy counteracts the weight of the fluid, and it is governed by the Archimedes principle, which states that the buoyant force is equal to the amount of fluid displaced by the object.
Now, there are three types of buoyancies. The first one is positive buoyancy. In this, the object immersed in water remains up above the water level. And the second one is negative buoyancy. In this, the body immersed in water remains below water line. And in third, neutral buoyancy, the object is neither sink and neither floating, that is partially sinking and partially floating. Now, we are going to tell you about the relation between surface area and buoyancy.
Surface area plays a major role in the concept of buoyancy. For example, we have two papers here. This one has been shaped like a rock. If we put this into the water, it will sink down. But this one has been made into a boat. If we put this in the water, it will float. This happens because of the surface area of the two papers.
Now, application of buoyancy and how it impacts us in our daily life. The first one is during floating or swimming, we know that we remain afloat. This is because the body of the swimmer displaces enough water that will prevent it from sinking. The second example is ships and boats. In ships and boats, the weight of the vessel or the container is taken into consideration to displace enough water that will counteract the weight of the boat and prevent it from sinking. Third example is hot air balloons. In hot air balloons, the air inside the balloon are heated so that it becomes less dense than the surrounding air, and it has the buoyant force that lifts it up.
The concept of buoyancy is also used by divers. They use BCDs, also known as buoyancy control devices, to help in their diving experience. It is also used by submarines. Submarines use their ballast tanks to help with their buoyancy control. The concept of buoyancy is also used in cold and hot air ventilation. So as we all know that colder air is more dense than hotter air. So we make ventilators on top of the room. So now, by rule, warmer air moves upward and moves out through the ventilators.
Now, we will start with our experiment. Today, we are presenting the dancing races experiment. Here, I have two glasses. In one, I have normal glass. Now, I will drop some raisins in it and observe how they sink because their density is more than that of water. But in this glass, I have a mixture of baking soda and vinegar. Now, in this,
baking soda and vinegar create a reaction which produces carbon dioxide, as we can see.
Now I will drop some raisins and carefully observe when they interact with dissolved carbon dioxide. The raisins will appear to dance, showcasing buoyancy in a playful way. This is because this irregular surface of the raisins provide nucleation site for carbon dioxide, which makes the raisins float.
The bubbles of the carbon dioxide gas surrounds the raisin, which makes its overall density lighter than that of the fluid. So it comes up to the surface and floats. But after the bubbles of the carbon dioxide escape, the raisin becomes more denser than the fluid again. Thus, it sinks back down, creating a dancing motion.
You will see that the raisins are coming up and going down. The concept of buoyancy not only affects us in our daily life, it also has exciting application in various fields. Thank you.